In this video, I am going to explain you lung volumes and capacities in such a way that you will never forget it in your life. Let's start. So let us first draw a container. And this is a pipe. This container can be considered as a lung. This pipe can be considered as bronchi. Air enters and leaves the lungs through bronchi. Now let us draw three lines. 1, 2, and 3. Now you should note that in this compartment air is present, and in this compartment air is present, and in this compartment air is present, but in this compartment air is absent. So this compartment is empty. The volume of air in this compartment do not take part in respiration. Once again, the volume of air in this compartment do not take part in respiration, hence, and this volume in this portion is called residual volume. So the volume of air in this compartment do not take part in respiration, and it is called residual volume. Since residual volume do not take part in respiration, it cannot be measured by spirometry. So residual volume cannot be measured by spirometry. The volume of air in this compartment takes part in normal respiration. Air moves into and out of the lungs during normal respiration in this compartment, and this compartment volume is called tidal volume. This compartment volume takes part in normal respiration and it is called tidal volume, and normal tidal volume is 500 ml. The volume of air in this compartment only takes part during forceful expiration. Once again, the volume of air in this compartment only takes part during forceful expiration. It do not take part during normal expiration. And this portion of volume is called expiratory reserve volume. So the volume of air that can be exhaled during forceful expiration is expiratory reserve volume. Normally, this empty space is not filled with air, but during forceful inspiration, only during forceful inspiration, this part gets filled with air, and this part is called inspiratory reserve volume. So this portion is called residual volume, this portion is called expiratory reserve volume, and this portion is called tidal volume, and this portion is called inspiratory reserve volume. So the tidal volume, volume of air that moves into and out of the lungs during normal respiration, that is normal inspiration and normal expiration. Tidal volume is equals to 500 ml. Residual volume, volume of air in lungs that do not take part in respiration. Since residual volume do not take part in respiration, it cannot be measured by spirometry. Expiratory reserve volume, volume of air that can be exhaled during forceful expiration. Expiratory reserve volume do not take part during normal expiration. Inspiratory reserve volume, empty space which is not filled with air. This empty space can be filled during forceful inspiration. This empty space do not take part during normal inspiration. Lung capacities. Lung capacities consist of two or more lung volumes added together. Inspiratory capacity. Inspiratory capacity is tidal volume plus inspiratory reserve volume. Vital capacity. Vital capacity is maximal volume of air that can be exhaled after a maximal inspiration. The best example to describe vital capacity is blowing candles on your birthday. Vital capacity is equals to inspiratory reserve volume plus tidal volume plus expiratory reserve volume. Functional residual capacity. Volume of air in lungs after normal expiration. Residual volume plus expiratory reserve volume is functional residual capacity. One very important point is, at functional residual capacity, pulmonary vascular resistance is minimum because the inward pull of the lungs is balanced by the outward pull of the chest wall. Total lung capacity. Total volume of air the lung can accommodate. Total lung capacity is vital capacity plus residual volume. Total lung capacity is 6 liters. You should also note that any capacity that includes residual volume cannot be measured by spirometry. Example, functional residual capacity and total lung capacity. Both of these contains residual volume, hence cannot be measured by spirometry. So this is the final diagram of lung volumes and capacities. This and this together forms inspiratory capacity. This and this and this will form vital capacity, and this and this will form functional residual capacity, and all of this combined together forms total lung capacity. Thank you.